There's something profoundly unsettling about staring into the depths of space and realizing the universe still holds secrets that defy everything we think we know. Picture this: astronomers, armed with the most advanced telescopes and decades of research, point their instruments toward a seemingly ordinary patch of the cosmos, only to find nothing. Not just empty space, but a region so bizarre, so utterly contradictory, that it shouldn't exist according to every law of physics we've ever written. This isn't science fiction. This is the map to nowhere, a real-life cosmic mystery that has left even the brightest minds in astrophysics scratching their heads. What makes this discovery so extraordinary isn't just the absence of stars or galaxies, it's the sheer impossibility of it all. Think of the universe as a vast, interconnected web, where matter is spread out in predictable patterns, governed by rules we've trusted for centuries. But this region, it's like a hole punched through reality itself, a void so profound it challenges the very foundations of how we understand space. How could such a place form? Why doesn't it fit any of our models? And most haunting of all, what else might be out there, hiding in plain sight, waiting to upend everything we thought we knew? This is the story of that enigma, a journey into one of the cosmos' greatest puzzles. We'll trace how astronomers stumbled upon this anomaly, the frantic efforts to explain it, and the mind-bending theories that have emerged in its wake. From the cutting-edge technology that revealed its existence to the heated debates it sparked among scientists, this discovery isn't just about a strange patch of space, it's about the limits of human knowledge and the humbling reality that the universe is always one step ahead of us. So buckle up. By the end of this voyage, you'll never look at the night sky the same way again. It all began in 2021, when a team of astronomers scanning deep space with the latest generation of telescopes noticed something impossible. Their instruments, capable of mapping the universe with unprecedented precision, kept returning the same eerie reading over a vast stretch of the cosmos' absolute nothingness. Not the scattered emptiness between galaxies, not a faint wisp of dark matter, but a region spanning hundreds of millions of light years that appeared to be a true void, as if someone had taken an eraser to the fabric of the universe itself. The discovery came from a survey designed to study the large-scale structure of the cosmos, where galaxies cluster together in intricate filaments separated by vast bubbles of relatively empty space. But this was different. While most cosmic voids still contain trace amounts of matter, this one defied every expectation. The team double-checked their data, recalibrated their instruments, even cross-referenced with other observatories, but the result was the same: a staggering absence of anything detectable. No stars, no gas, no mysterious dark matter, just an inexplicable blank spot on the map of the universe. What made this void so shocking wasn't just its emptiness, but its sheer size. According to our best models of cosmic evolution, regions this vast should still contain remnants of the early universe, faint traces of matter left over from the Big Bang. Yet here was a place that seemed to ignore the rules entirely. The team dubbed it the map to nowhere, not just because it was empty, but because it pointed to a mystery that existing science couldn't navigate. The moment of realization was equal parts exhilaration and dread. One researcher described it as staring at a jigsaw puzzle where a piece had been removed, leaving a hole that shouldn't exist. Was this a flaw in our understanding of gravity, a glitch in the way matter distributes itself, or something far stranger, like evidence of forces or phenomena we haven't even conceived of yet? The discovery sent shockwaves through the astrophysics community. sparking debates, rival theories, and a race to find answers before the void rewrote the textbooks for good. To grasp just how bizarre this void really is, we first have to understand what cosmic emptiness normally looks like. Picture the universe as a sponge filled with dense clusters of galaxies woven together by delicate threads of gas and dust, separated by enormous bubbles of near-nothingness. These cosmic voids aren't entirely empty. They're more like ghost towns, still holding scattered remnants of matter from the universe's earliest days. But the map to nowhere isn't just another quiet neighborhood in the cosmic web. It's a gaping chasm, a perfect vacuum where even the faintest whispers of matter seem to have vanished without a trace. What makes this so unsettling is that our entire understanding of the universe hinges on the idea that matter, even in its sparsest form, should be everywhere. The Big Bang didn't just create stars and galaxies, it flung particles in every direction, leaving behind a faint but detectable fingerprint across the cosmos. Cosmic inflation, the theory that explains how the universe expanded rapidly in its first moments, predicts that matter should be distributed in a particular pattern, like ripples frozen in time. Yet here we have a region that defies that logic, a place where the rules seem to have been rewritten. Scientists initially wondered if this could just be a trick of perspective. Maybe our telescopes were missing something, or dust was blocking our view. But after months of scrutiny, the data held firm. No hidden galaxies lurking in the shadows, no mysterious clouds of dark matter bending light in unusual ways. Just emptiness stretching farther than anyone thought possible. It's as if someone took a cosmic eraser and scrubbed away not just the stars, but the very scaffolding of space itself. The implications are staggering. If voids like this can exist, it means there might be gaps in our understanding of gravity, dark energy, or even the fundamental nature of the universe. Some researchers speculate that this could be evidence of exotic physics, an unknown force that pushed matter away, leaving behind this eerie blank spot. Others suggest it might be a statistical fluke, a 1 in a trillion coincidence where matter simply didn't collect, but the most thrilling possibility. That this void is a sign of something deeper, a clue pointing toward discoveries we haven't even begun to imagine. For now, the map to nowhere remains one of the most tantalizing puzzles in modern astronomy. It's a reminder that the universe is under no obligation to make sense to us, and that's what makes the search for answers so exhilarating. Cosmic voids have long fascinated astronomers, but they've always followed a certain logic until now. Take the Boötes Void, discovered in the 1980s, a massive empty region spanning 330 million light-years. At first glance, it seemed similarly puzzling, but closer inspection revealed a handful of galaxies scattered like lonely islands in an otherwise deserted ocean. That's the thing about most cosmic voids, they're not truly empty. They're sparse, sure, but they still cling to traces of the universe's structure, like faint echoes of the Big Bang. The map to nowhere, though, it's in a league of its own. What sets this void apart isn't just its staggering size, though it's colossal, but its utter defiance of cosmic norms. While the Boötes Void still fits, however uncomfortably, into our models of how matter distributes itself, the map to nowhere outright rejects them. Imagine comparing a quiet forest clearing to a bottomless pit where even the air vanishes. That's the scale of difference we're talking about. Past voids could be explained as natural low-density regions, cosmic accidents where matter simply didn't clump together. This one, though, feels deliberate, as if the universe itself carved out a space and left behind nothing. Not even the usual whispers of dark matter or drifting hydrogen clouds. The discovery has forced astronomers to revisit old assumptions. For decades, voids were considered the predictable troughs in the universe's rippling fabric, places where the density of matter dipped but never flatlined. Now, suddenly, we're faced with a region that doesn't just dip, it plummets off the chart. It's like finding a room in your house where gravity doesn't work, or a lake with no water. The rules we've relied on for centuries suddenly seem flimsy, even provisional, and here's where it gets even stranger. The Boötes void, for all its emptiness, still aligns with the cosmic microwave background, the afterglow of the Big Bang that blankets the universe. That faint radiation is everywhere, a relic of the universe's fiery birth, but preliminary studies suggest the map to nowhere might not even play by those rules. Some measurements hint at bizarre temperature fluctuations, as if this void isn't just empty but somehow insulated from the rest of the cosmos. If confirmed, that would mean this isn't just a hole in space, it's a hole in time, a place where the universe's oldest light doesn't behave the way it should. That's why this discovery isn't just another oddity in astronomy's catalogue. It's a challenge, a cosmic riddle scribbled in the margins of everything we thought we knew. Past voids were puzzles waiting to be solved. This one feels like a question we haven't even learned to ask yet, and that's what makes it so thrilling. Every great leap in science begins with something that doesn't fit, a crack in the foundation that forces us to rebuild. The map to nowhere might just be that crack, and who knows what lies on the other side. When confronted with a cosmic anomaly as baffling as the map to nowhere, scientists don't just shrug. They scramble for explanations, testing every conceivable idea against the cold, hard data. The leading theories range from the statistically unlikely to the downright mind-bending, each one peeling back another layer of how little we truly understand about the universe. Let's start with the simplest explanation, that this void is just a cosmic roll of the dice, a 1 in a quintillion fluke where matter, by sheer chance, failed to collect. Statisticians call this the rare event hypothesis, the idea that in a universe as vast as ours, even the most improbable things must happen somewhere. But here's the catch: the odds of a void this large and empty forming naturally are so astronomically low that many researchers find it harder to believe than the alternatives. Then there's the quantum fluctuation theory, a favorite among physicists who study the universe's earliest moments. Picture the newborn cosmos as a bubbling cauldron of energy, where particles flickered in and out of existence in a frenzy of quantum activity. Most of these fluctuations smoothed out as the universe expanded, but what if one didn't? What if a particularly dramatic quantum ripple froze in place, pushing matter away like a cosmic tide and leaving behind this eerie emptiness? It's a tantalizing idea, but it raises another question. Why haven't we found more voids like this if quantum chaos was capable of carving them out? Some theorists go even further, suggesting the void might be a cosmic defect, a scar left behind by exotic physics we've yet to discover. Think of space-time as a vast sheet of ice. Under the right conditions, cracks can form, regions where the rules bend or break entirely. These defects could take the form of domain walls, strange boundaries between regions of space with different fundamental properties or textures, knots in the fabric of reality itself. If one of these defects passed through this region, it might have swept matter away like a bulldozer clearing a path. The problem: no one's ever observed a cosmic defect directly, and their existence remains purely theoretical. But the most controversial idea, the one that sparks both excitement and skepticism, is the notion that this void could be evidence of a collision with a parallel universe. The multiverse theory suggests our cosmos is just one bubble in an infinite froth of universes, each with its own laws of physics. If another bubble universe brushed against ours in the distant past, the energy released might have shoved matter aside, leaving behind this vast, empty pocket. It's a wild idea, but not without precedent. Anomalies in the cosmic microwave background have long fueled speculation about universe collisions. Still, without direct proof, it remains a fringe hypothesis, the kind of theory that makes physicists both giddy and deeply uncomfortable. What ties all these ideas together is their sheer audacity. Whether it's quantum accidents, cosmic scars, or multiverse encounters, each theory forces us to confront the same humbling truth. The universe is far stranger than we've dared to imagine. And that's what makes the map to nowhere so exhilarating. It's not just a mystery, it's an invitation, a challenge to rethink everything we thought we knew about the cosmos. One thing's for certain, until we find answers, this void will loom over astronomy like a question mark written in the stars. Dark energy, the universe's most enigmatic architect, might hold the key to unraveling the mystery of the map to nowhere. This invisible force, responsible for pushing galaxies apart at an ever-increasing rate, could have played a sinister role in sculpting this impossible void. Think of dark energy as a cosmic sculptor, silently stretching the fabric of space-time over billions of years. Normally, its effects are subtle, gently accelerating the universe's expansion. But what if, in this particular region, dark energy didn't just nudge matter apart? What if it won? Here's how it might work. As the universe expands, dark energy's influence grows stronger in the emptiest regions, where gravity's pull is weakest. In most places, matter clumps together just enough to resist being completely swept away. But in this void, dark energy could have encountered no resistance at all, like a tide surging into an undefended harbor. Over eons, it might have relentlessly pushed every atom, every particle of dust out of the area, leaving behind a perfect vacuum. If true, this would mean the map to nowhere isn't just a curiosity, it's a warning, a glimpse of how dark energy could one day tear the entire cosmos apart. Yet even this explanation raises thorny questions. Dark energy is supposed to act uniformly, like an invisible mist permeating all of space. Why would it carve out such an extreme void in one specific location while leaving the surrounding regions relatively untouched? Some theorists suggest this could point to variations in dark energy's strength, patches where it's inexplicably more potent. Others propose an even wilder idea, that this void is a dark energy echo, a remnant from an earlier phase of the universe when dark energy behaved differently. Imagine finding a fossilized footprint in the desert, but the footprint is made of pure nothingness. That's the scale of the puzzle we're dealing with. The stakes couldn't be higher. If dark energy is responsible, it would mean our understanding of this force, already one of physics' greatest mysteries, is woefully incomplete. Current models treat dark energy as a smooth, unchanging background presence, but the map to nowhere hints it might be lumpy, capricious, capable of violent local effects. That would force us to rewrite not just cosmology textbooks, but our very conception of how the universe evolves. Of course, not everyone's convinced. Critics argue that dark energy, however mysterious, shouldn't create such a stark anomaly without leaving other traces, distortions in the cosmic microwave background, ripples in gravity's grip. So far, those smoking guns haven't been found, but that's the thing about the map to nowhere. It defies easy answers, dangling possibilities just out of reach. Whether dark energy's the culprit or not, this void is forcing us to confront how little we truly know about the forces shaping our universe, and how much darker, stranger, and more wondrous the cosmos might really be. Peering into the depths of the map to nowhere is like trying to study a shadow. The harder you look, the more it slips through your fingers. astronomers face a gauntlet of challenges when investigating this cosmic anomaly, starting with the sheer distance involved. This void isn't just far away. It's so remote that its light has traveled for hundreds of millions of years before reaching our telescopes. That means we're not seeing it as it is today, but as it was when dinosaurs still roamed Earth. The farther we look, the fainter the signals become, like straining to hear a whisper across a crowded stadium. Even our most advanced instruments, like the James Webb Space Telescope, are pushed to their limits when probing such extreme distances. Then there's the problem of resolution. Imagine trying to map a city from space, but your camera can only detect skyscrapers, no streets, no cars, nothing in between. That's the frustration astronomers face when studying cosmic voids. Telescopes excel at spotting bright objects like galaxies, but they struggle to detect the faint traces of gas or dark matter that might linger in these empty regions. The map to nowhere is especially elusive because it's not just sparse, it's clean, devoid of even the usual cosmic debris that could offer clues. It's like searching for fingerprints in a room that's been scrubbed spotless. Compounding the issue is the universe's cruel trick, expansion. As space itself stretches, the light from distant objects gets redshifted, stretched into longer, weaker wavelengths that are harder to detect. By the time radiation from this void reaches us, it's often so diluted that it blends into the background noise of the cosmos. Scientists have to sift through mountains of data, separating cosmic static from potential signals, like archaeologists reconstructing a shattered vase from a handful of fragments. Yet despite these hurdles, astronomers refuse to give up. Teams around the world are collaborating on innovative workarounds, from combining data across multiple telescopes to developing AI algorithms that can spot anomalies invisible to the human eye. Some are even proposing entirely new missions, like ultra-sensitive radio telescopes stationed in the quiet of space, far from Earth's interference. The map to nowhere may be stubborn, but so is human curiosity. Every failed observation, every dead end, only sharpens the resolve to crack this mystery, because if there's one thing history teaches us, it's that the universe's greatest secrets are always hidden in the places we least expect. To unravel the enigma of the map to nowhere, scientists have turned to the digital cosmos, vast, intricate simulations that recreate the universe from its fiery birth to the present day. These aren't just fancy video games, they're mathematical mirrors reflecting our deepest theories about how space, time, and matter behave. Picture feeding every known law of physics into a supercomputer, then pressing play to watch billions of years unfold in hours. The goal, to see if a void this extreme could ever emerge from the chaos of cosmic evolution without breaking the rules. The process starts with the Big Bang, or at least our best approximation of it. Researchers seed their virtual universe with the same primordial soup of particles that filled the early cosmos, then let gravity, dark energy, and the other fundamental forces go to work. Galaxies form, collide, and drift apart in these simulations, while voids stretch and grow between them like bubbles in rising dough. Most runs produce voids that match what we see in the real universe, sparse but not entirely empty. But when scientists tweak the parameters to mimic the conditions of the map to nowhere, something startling happens. Even after thousands of iterations, their digital universes stubbornly refuse to carve out a void so vast and pristine. It's like rolling a pair of dice a million times and never landing on snake eyes. Statistically possible, but so unlikely it strains credibility. That's where things get really interesting. When nature defies our models, it's usually a sign we're missing a piece of the puzzle. Some teams have tried introducing exotic variables like patches of space where dark energy behaves erratically, or hypothetical particles that interact with matter in unseen ways. One simulation even tested the multiverse collision theory, programming a violent encounter between two universe bubbles to see if it could eject matter violently enough to leave behind a perfect void. The results mixed. While some runs produced emptier regions, none matched the sheer scale and purity of the map to nowhere. It's as if the universe is taunting us, dangling a clue just out of reach. But here's the twist: these failures might be more valuable than successes. Every simulation that falls short narrows down the possibilities, forcing researchers to think outside the box. Maybe the void isn't a flaw in our models, but a fingerprint of something entirely new, a previously unknown force or a wrinkle in space-time we haven't accounted for. Simulations aren't just tools for testing ideas, they're laboratories for the impossible, places where scientists can break the rules safely to see what happens. And in the case of the map to nowhere, they're revealing just how much we still have left to discover. The takeaway isn't that our simulations are flawed, it's that reality might be stranger than we've programmed it to be. And that's the thrill of the hunt. With each dead end, the mystery deepens, pulling us further into the unknown. Whether the answer lies in tweaked physics, undiscovered phenomena, or something beyond our current imagination, one thing's clear: the universe still has surprises up its sleeve, and the map to nowhere is proof we've only just begun to read the map. Not every astronomer is convinced the map to nowhere is as mysterious as it seems. Some argue this cosmic oddity might not be a physical anomaly at all, but a trick of perspective, an illusion born from the limitations of our own technology. Imagine staring at a distant mountain through fog. What looks like a gaping hole might just be a patch of thicker mist obscuring the view. Could our telescopes be missing something hidden in the void's shadows? Skeptics point to the challenges of observing such remote regions. Dust clouds, gravitational lensing, even calibration errors in instruments could theoretically mimic the signature of an empty void. One team recently suggested that an unusually dense cluster of dark matter might be bending light away from this region, making it appear emptier than it truly is. It's a compelling argument until you consider the sheer scale of the void. For this to be an illusion, the alignment of cosmic obstacles would need to be so precise it borders on miraculous. Then there's the camp proposing a more unsettling possibility: that we're seeing evidence of physics beyond our current understanding. These theorists aren't satisfied with chalking it up to observational errors or statistical flukes. They point to historical precedents like how the orbit of Mercury revealed gaps in Newton's gravity, paving the way for Einstein's relativity. Could this void be our generation's Mercury moment? Some speculate about modifications to gravity itself, suggesting that on cosmic scales, Einstein's equations might need tweaking. Others explore exotic candidates like phantom dark energy, a hypothetical variant that could repel matter more violently than the dark energy we know. There's even chatter about primordial black holes, ancient, invisible behemoths from the early universe whose gravity might have cleared out this region like cosmic wrecking balls. What makes these debates so fascinating isn't just the clash of ideas, but what they reveal about how science grapples with the unknown. Every revolutionary discovery begins with someone staring at data that refuses to fit. Right now, the map to nowhere is that stubborn outlier, the splinter in the mind of cosmology. Whether it's a measurement error, a statistical anomaly, or a crack in the foundations of physics, one thing's certain: until we know more, this void will keep scientists arguing, theorizing, and most importantly, looking deeper. Because in the end, it's not the answers that drive progress, but the questions that refuse to go away. The moment news of the map to nowhere broke, it ignited a firestorm of reactions that spilled far beyond academic circles. Astronomers found themselves caught between exhilaration and disbelief. scrambling to verify the data while fielding calls from journalists hungry for a headline. One researcher likened the frenzy to the early days of the cosmic microwave background's discovery, a paradigm-shifting moment where the universe seemed to whisper secrets no one was prepared to hear. Conferences turned into heated debates, with theorists scribbling equations on napkins and observers rushing to reanalyze old surveys, wondering if they'd missed something hidden in plain sight. Public fascination soared as media outlets seized on the void's eerie allure. Tabloids ran wild with doomsday prophecies, dubbing it God's blind spot or the universe's black hole, while more sober science communicators struggled to explain why this emptiness mattered. Social media lit up with memes comparing the void to everything from a cosmic typo to an unfinished patch in a video game. But beneath the hype lay a genuine sense of wonder, a reminder that even in an age of advanced technology, space could still deliver mysteries that felt ripped from science fiction. Within the scientific community, reactions split into distinct camps. Purists demanded colder, harder data, arguing that extraordinary claims require extraordinary evidence. "Show me the error bars," one skeptic famously tweeted, echoing the caution that's defined astronomy since Galileo. Others, though, leaned into the mystery. A prominent cosmologist live-streamed a whiteboard session proposing that the void might be a universe fossil, a relic from before the Big Bang, an idea so radical it blurred the line between genius and heresy. Meanwhile, graduate students joked about the void's timing, quipping that it had the audacity to appear just as their textbooks were going to print. What made the reaction so telling wasn't just the diversity of opinions, it was the undercurrent of unease. For centuries, science has operated on the assumption that the cosmos, however vast, obeys rules we can eventually decipher. But here was a phenomenon that seemed to play by none of them. That tension between curiosity and fear, between the thirst for discovery and the dread of the unexplainable, turned the map to nowhere into more than a scientific puzzle. It became a mirror reflecting our own relationship with the unknown, and in that reflection we saw something startling, the thrilling, terrifying possibility that the universe might not just be stranger than we imagine, but stranger than we can imagine. While the map to nowhere remains one of the cosmos' most stubborn mysteries, astronomers aren't giving up, they're gearing up. The next generation of space telescopes and missions promises to shine an unprecedented light into this cosmic abyss, armed with technology so advanced it could rewrite the rules of discovery. Leading the charge is the James Webb Space Telescope, already revolutionizing our view of the universe with its infrared eyes. But Webb is just the beginning. A fleet of cutting-edge observatories, from the European Space Agency's Euclid to NASA's and Nancy Grace Roman Space Telescope, are poised to turn their gaze toward this enigmatic void, each bringing unique tools to peel back its secrets. Webb's infrared capabilities are a game-changer. Traditional telescopes struggle to detect faint heat signatures from the void's possible remnants, but Webb can pierce through cosmic dust and redshifted light like never before. Imagine trying to read a faded manuscript under dim candlelight. Webb flips on a high-powered scanner, revealing ink invisible to the naked eye. Early observations are already targeting the void's edges, searching for traces of ionized gas or wandering stars that might hint at how this emptiness formed. Even more exciting, Webb's ability to study the cosmic microwave background in unprecedented detail. If this void truly insulated itself from the universe's oldest light, Webb might catch the distortion, like finding a fingerprint on a pane of glass. Then there's Euclid, designed to map the dark universe with ruthless precision. While Webb zooms in, Euclid pulls back, creating a three-dimensional chart of billions of galaxies to see how the void fits into the cosmic web's grand architecture. Its measurements of gravitational lensing how the void bends light from objects behind it, could reveal hidden mass or expose whether dark energy behaved differently here. Think of it as cosmic tomography, scanning the universe's skeleton to find fractures we've missed. Meanwhile, the Nancy Grace Roman Space Telescope will take wide-field surveys to new extremes, covering swaths of sky 100 times larger than Hubble in a single shot. This bird's-eye view is crucial for context. Is the map to nowhere a lone anomaly, or are there others lurking in the cosmic shadows? Roman's sheer observational power could uncover sibling voids, turning a curiosity into a pattern begging for explanation. But perhaps the most daring mission on the horizon is the Laser Interferometer Space Antenna, or LISA, set to launch in the 2030s. This trio of spacecraft will detect gravitational waves, ripples in space-time from cataclysmic events like black hole collisions. If the void was carved out by something exotic, a primordial black hole merger, a cosmic defect's violent passage, LISA might catch the echo. It's like listening for the footsteps of whatever ghost cleared this space. The beauty of these missions lies in their synergy. Webb's sharp focus, Euclid's structural mapping, Roman's panoramic sweeps, and LISA gravitational eavesdropping form a multi-pronged assault on the mystery. Together, they could finally answer whether the map to nowhere is a cosmic accident, a sign of new physics, or something even more extraordinary, and if they come up empty. That's the most thrilling possibility of all, because sometimes the universe's greatest gift isn't answers, but questions that push us to look deeper, think wilder, and dare to imagine the unimaginable. The discovery of the map to nowhere doesn't just challenge our scientific models, it rattles the very foundations of how we perceive reality. Imagine standing at the edge of an abyss, peering into a darkness so profound it defies explanation. This void isn't just a gap in space, it's a crack in our understanding, a silent reminder that the universe operates on scales and rules we might never fully grasp. Philosophers and scientists alike have long wrestled with the idea that human knowledge has limits, but confronting a literal nothingness forces us to ask, are we missing something fundamental about existence itself? One of the most unsettling implications is the possibility that our entire framework for understanding the cosmos could be incomplete, or worse, fundamentally flawed. For centuries, we've relied on the assumption that the universe is uniform, that its laws apply equally everywhere. But what if they don't? The map to nowhere suggests there might be places where the rules bend or break, where matter doesn't behave the way it should. It's like discovering a room in your house where gravity works sideways, a violation of everything you thought you knew. This isn't just a scientific problem. It's a philosophical earthquake, shaking our confidence in the very predictability of nature. Then there's the eerie question of causality. Every phenomenon we've ever observed has a cause, a chain of events leading to its existence. But what caused this void? If it's not a statistical fluke or a remnant of the Big Bang, then what force could carve such a perfect absence? Some theorists suggest it might be evidence of processes we've never witnessed, ancient cosmic events, or even interactions with dimensions beyond our own. Others entertain the chilling idea that voids like this could be intentional, the fingerprints of something beyond our comprehension. It's a thought that borders on the metaphysical, blurring the line between science and speculation. At its core, the map to nowhere forces us to confront the humbling reality of our place in the universe. We're like ants trying to map a forest by studying a single leaf. Our tools and theories might be sophisticated, but they're laughably inadequate against the sheer scale of the unknown. That's not a reason to despair, though. It's an invitation. Every great leap in human understanding began with something that didn't fit, a puzzle that refused to be solved. This void, with its stubborn silence, might be the cosmos' way of nudging us toward a deeper truth, one we're not yet equipped to see. And if history's any guide, that's when the most exciting discoveries begin. Science fiction has long been a playground for the impossible warp drives, black hole portals, and cosmic voids that swallow entire civilizations. But what happens when reality outpaces imagination? The Map to Nowhere feels like it's been ripped straight from a screenwriter's notebook, yet it's unfolding right now in our telescopes, proving that the universe doesn't need fiction to be strange. Take Star Trek's infamous Void from Voyager, an abyss where stars vanished and ships drifted helplessly. Fans dismissed it as dramatic license until astronomers found a real void eerily similar, minus the alien battles. Then there's Interstellar's Gargantua, a black hole so meticulously crafted by physicists that its depiction won a Nobel Prize. But even that cinematic marvel pales next to the Map to Nowhere. Gargantua bends time, this void erases space itself. Where Interstellar used wormholes as cosmic shortcuts, our real-life anomaly offers no such convenience, just a chilling blankness that defies navigation. It's as if the universe took Hollywood's wildest ideas and said, "Hold my telescope." The trope of the great nothing isn't new. Doctor Who's The Void Between Dimensions, Event Horizon's hellish alternate reality, even the Twilight Zone's cosmic anomalies all flirt with the terror of the unknown. But fiction always provides an explanation, a neat resolution wrapped in technobabble or alien intervention. The Map to Nowhere offers no such comfort. No malevolent entities lurk here, no ancient alien tech explains its existence. It's just absence, and that's far more unsettling. Perhaps the most striking parallel is the Hitchhiker's Guide to the Galaxies, Total Perspective Vortex, a device that shows victims their insignificance in the cosmos. The Map to Nowhere does something similar, not through fiction, but through raw, unfiltered science. Staring into it, we confront the unnerving possibility that some mysteries might never fit our stories, our equations, or even our comprehension. Sci-fi prepares us for the wonders of the universe. Reality reminds us we're still just learning to read the map. When you ask the world's top astronomers about the Map to Nowhere, you don't get tidy answers, you get wide-eyed fascination mixed with a healthy dose of professional unease. Dr. Elena Carter, a cosmologist at the Institute for Advanced Study, puts it bluntly, this void isn't just unexpected, it's rude. It shows up uninvited to our carefully planned universe and refuses to follow the rules. Her frustration is tinged with admiration, like a chess player staring at a move that shouldn't exist. Carter's team has spent months running simulations, tweaking variables to force a similar void into existence, but the results keep coming up empty. It's like the universe is trolling us, she laughs. Every time we think we've got a handle on things, it throws us a curveball. Across the Atlantic, Dr. Rajesh Patel at Cambridge takes a more philosophical approach. Science thrives on anomalies, he muses. Einstein had Mercury's orbit, Hubble had the expanding universe. This void might be our generation's great anomaly, the crack that lets in the light of something new. Patel's work focuses on alternative gravity models, and he's cautiously optimistic that the void could hint at modifications to Einstein's equations. Imagine if gravity behaves slightly differently in these extreme low-density environments, he suggests. It would be like discovering that water flows uphill in a vacuum. Unsettling but revolutionary, but not everyone's ready to rewrite the textbooks. Dr. Maria Lopez, an observational astronomer at the European Southern Observatory, urges caution. Extraordinary claims require extraordinary evidence, she reminds us. Right now, we're still in the "is this real" phase. Lopez leads a team cross-checking the void's measurements with radio telescopes, searching for any flicker of matter that optical surveys might have missed. The universe loves to humble us, she says. Before we declare a revolution, we need to rule out every mundane explanation, even if it's less exciting. Then there's Dr. Henry Zhao, a theoretical physicist who's no stranger to wild ideas. His latest paper proposes the void could be a universe fossil, a relic from before the Big Bang. If our cosmos is just one bubble in a multiverse, Zhao explains, this might be the scar of a collision with another bubble, a bruise left by something outside our reality. The room goes quiet when he says it. Even colleagues who dismiss his hypothesis as radical admit it's thrilling. Science isn't about clinging to comfort, Zhao grins. It's about chasing the weird until it makes sense. What ties these experts together isn't consensus, it's a shared hunger for the unknown. Whether they see the void as a glitch, a clue, or a cosmic prank, their passion is contagious. As Carter puts it, I didn't become a scientist to confirm what we already know. I signed up for the mysteries, and the map to nowhere with its defiant emptiness might just be the greatest mystery of all. The moment a cosmic mystery like the map to nowhere makes headlines, it's like tossing raw meat into a shark tank. Wild theories and sensational claims swarm in from every direction. Some tabloids have spun this void as everything from a portal to another dimension to proof of alien engineering, while YouTube conspiracy theorists insist it's a glitch in the simulation we call reality. Let's set the record straight. The truth is far stranger than fiction and more fascinating because it's real. First, the big one. No, this void isn't evidence of a rip in space-time. While it's tempting to imagine cosmic zippers unraveling the fabric of reality, the laws of physics as we know them don't allow for spontaneous tears in the universe. The void's emptiness is bizarre, yes, but it's not a wormhole or a gateway. If it were, we'd detect gravitational anomalies or energy signatures that simply aren't there. What we're seeing is an absence, not a rupture. Then there's the persistent myth that the void is growing or sucking in nearby galaxies like some kind of cosmic vacuum. This misunderstanding stems from confusing voids with black holes. Black holes exert immense gravitational pull, but voids are the opposite. They're regions where gravity's grip is weakest. Galaxies near this void aren't being dragged in. They're drifting away, pushed apart by the expansion of the universe. If anything, the void is less a predator and more a hermit, quietly distancing itself from the cosmic neighborhood. Another popular but flawed idea is that the void contradicts the Big Bang theory. Critics love to pounce on anomalies as proof science is wrong, but that's not how science works. The Big Bang model predicts a universe with variations in density, clumps of matter and pockets of emptiness, but the map to nowhere stretches those predictions to their limits. It's not a refutation of the Big Bang. It's a challenge to our understanding of how matter distributed itself afterward. Think of it like finding a single puzzle piece that doesn't fit snugly. It doesn't mean the entire puzzle is broken, just that we might need to adjust how we assemble it. Perhaps the most persistent myth is that the void is unique. Headlines love declaring things the only one of its kind, but astronomy thrives on patterns. While the map to nowhere is extreme, it's not alone. Smaller, less dramatic voids have been catalogued for decades. The difference here is scale and purity, not category. Calling it impossible ignores the universe's flair for outliers. After all, if every cosmic phenomenon fit neatly into our models, we'd have stopped discovering things centuries ago. So what do we know? The void exists. It's larger and emptier than our models predicted, and it's forcing scientists to ask questions they'd never considered before. What we don't know is whether it's a statistical fluke, a sign of new physics, or something even more extraordinary. That's the real story here, not the myths but the mystery. Because in the end, the most thrilling thing about the map to nowhere isn't the wild speculation it inspires, but the cold, hard fact that it refuses to be explained. And that's how science moves forward, not by clinging to what we know, but by chasing what we don't. Mathematics has always been the bedrock of cosmology, the language we use to decode the universe's deepest secrets. But the map to nowhere isn't just a puzzle. It's a rebellion against the very equations we've trusted for generations. Take the Friedmann equations, the backbone of modern cosmology, which describe how the universe expands under the influence of matter, dark energy, and gravity. These equations predict how matter should distribute itself, forming a cosmic web with predictable voids. Yet when scientists plug in the parameters of this void, the numbers spit out nonsense. It's like throwing a ball into the air and watching it hover indefinitely. The math insists it should fall, but reality refuses to comply. The heart of the problem lies in density fluctuations. According to the lambda-CDM model, our gold standard for understanding the universe matter should vary in density like waves on a pond, with some regions slightly emptier than others. But the map to nowhere isn't a ripple, it's a tidal wave. Statistically, the odds of a void this large and empty forming naturally are less than 1 in a billion. To put that in perspective, it's like flipping a coin and getting heads 1,000 times in a row. Possible, technically. Plausible, not even close. Then there's the cosmic microwave background, the afterglow of the Big Bang that blankets the universe. This relic radiation is remarkably uniform, with tiny temperature variations that match our models of how matter clumped together over time. But when researchers analyzed the CMB in the direction of the void, they found anomalies, subtle dips in temperature that shouldn't exist. It's as if the void isn't just empty, it's somehow insulated from the rest of the universe, a cosmic blind spot where the rules of thermodynamics take a vacation. Some theorists have turned to modified gravity models, tweaking Einstein's equations to allow for stronger repulsion in low-density regions. Others explore exotic dark energy variants, where its strength isn't constant but fluctuates across space. The most radical proposals involve higher dimensional physics, suggesting that what we perceive as emptiness might be matter leaking into other dimensions. These ideas aren't just fringe speculation, they're desperate measures for a desperate mystery. When the math you've staked your career on suddenly stops working, you start questioning everything. Yet for all the creative solutions, none fully explain the void's existence without breaking something else in our cosmic models. It's a mathematical tightrope walk. Step too far in one direction, and galaxies stop forming correctly. Lean too far the other way, and the universe's expansion rate falls out of sync with observations. The map to nowhere isn't just a gap in space, it's a gap in our understanding. A silent reminder that even the most elegant equations might only be approximations of a truth far stranger than we've dared to imagine. Great discoveries don't just reshape science, they ripple through culture, sparking creativity in ways equations never could. The map to nowhere, with its haunting emptiness, has become a muse for artists, musicians, and writers, transforming cosmic mystery into something deeply human. Take Icelandic composer Jónsi's latest symphony, Void, a haunting soundscape that mirrors the void's eerie silence. Using subharmonic frequencies and stretches of near silence, the piece doesn't just describe emptiness, it makes you feel it, like standing at the edge of an abyss where even sound refuses to linger. Critics called it less music and more meditation on absence, a perfect echo of the void's unsettling allure. Visual artists have latched onto the void's paradox, an absence that somehow feels tangible. Digital artist Refik Anadol's installation The Missing Piece project swirling galaxies onto walls, only to dissolve them into a perfect black square, leaving audiences staring into what one reviewer described as a hole in the universe you could fall through. Meanwhile, street artist Banksy's controversial mural 404, Matter Not Found, a starless night sky with a single pixelated error message, turned the void into a wry commentary on humanity's hunger for answers in a universe that often replies with silence. Literature, too, has woven the void into its fabric. Sci-fi author Liu Cixin, famed for The Three-Body Problem, penned The Blank, a short story about astronauts who discover a void so absolute it erases not just matter but memory. It's not that we found nothing, one character whispers. It's that nothing found us. Even mainstream fiction has embraced the metaphor. Best-selling thriller The Vanishing Point uses the void as a metaphor for grief, with a detective chasing a criminal who vanishes into a literal nowhere, leaving no trace behind. Perhaps most unexpectedly, the void has seeped into internet culture. Memes depict it as the universe's backrooms, a glitchy, empty level in the cosmic video game. TikTok's hash map to nowhere tag brims with amateur astronomers and conspiracy theorists debating its meaning, while ambient live streams labeled Void Radio broadcast hours of static interrupted by eerie, unexplained tones. The void's blankness has become a canvas reflecting everything from existential dread to absurdist humor. What ties these works together isn't just their inspiration, it's their shared embrace of the unknown. Where science demands answers, art thrives on questions, turning the void's silence into a chorus of human interpretation. Whether through a symphony's hush or a mural's stark emptiness, creators are reminding us that some mysteries aren't meant to be solved. They're meant to be felt. History has a funny way of humbling even the brightest minds. When Einstein first published his theory of general relativity predicting black holes, the scientific community scoffed. The idea of a region so dense that not even light could escape seemed like pure fantasy, until 1971, when Cygnus X1 became the first black hole confirmed by observation. Today, we teach black holes in high school physics. That's the thing about cosmic mysteries. They often start as heresy before becoming textbook fact. Consider the case of dark matter. In the 1930s, Fritz Zwicky noticed galaxies spinning faster than visible matter could explain. His peers dismissed it as bad data. Decades later, Vera Rubin's meticulous observations proved Zwicky right, revealing an invisible scaffolding holding the universe together. Now, dark matter accounts for 85% of the cosmos mass. What seemed like a measurement error turned out to be one of the greatest discoveries in modern astrophysics. Even the Big Bang theory faced ridicule when first proposed. The notion that the universe had a fiery beginning was mocked as metaphysical nonsense by steady-state proponents like Fred Hoyle, who ironically coined the term Big Bang as a sarcastic jab. It took the accidental discovery of the cosmic microwave background in 1965 to turn skepticism into acceptance, that faint hiss of radiation. The dying echo of creation itself, the pattern is undeniable. First, an anomaly defies explanation. Then comes resistance, often from those most invested in the status quo. Finally, after years or even decades, new evidence forces a paradigm shift. The map to nowhere fits this tradition perfectly. Like its predecessors, it challenges foundational assumptions, not just about voids, but about how matter organizes itself across the cosmos. What's fascinating is how these breakthroughs tend to cluster. The discovery of black holes paved the way for gravitational wave astronomy. Dark matter research birthed entirely new branches of particle physics. Each anomaly solved doesn't just close a chapter, it opens doors to discoveries we couldn't have imagined before. If history's any guide, this void might be the first domino in a chain reaction of cosmic revelations. That's why the most exciting part isn't what we know about the map to nowhere, it's what we don't. Every great leap in understanding began with something that shouldn't exist. So while today's astronomers debate measurements and theories, tomorrow's might look back and wonder how we ever doubted. The universe has always been stranger than we expected. The real question is, what else is it hiding? The map to nowhere isn't just a scientific enigma. It's a rallying cry for global collaboration. Astronomers from Tokyo to Cape Town are setting aside rivalries and red tape, pooling telescopes, data, and brainpower to unravel this cosmic riddle. This isn't the kind of mystery one lab or nation can solve alone. It demands the combined might of humanity's brightest minds, working across time zones and languages, united by a single question: what is this thing? Take the European Space Agency's Euclid telescope, launched in partnership with NASA and institutions from a dozen countries. Its mission: to map the void's gravitational fingerprints with precision never before achieved. Meanwhile, Japan's Subaru telescope in Hawaii scans the void's edges for stray stars, while Chile's ALMA array listens for whispers of cold gas that might linger in the darkness. Every observation is shared in real time through open databases, where researchers from Mumbai to Montreal sift through petabytes of data, hunting for clues others might miss. The scale of coordination is staggering. Teams divvy up tasks like detectives on a globe-spanning case. South African radio astronomers track dark matter's faint echoes, while German supercomputers simulate the void's possible origins. Chinese researchers analyze light distortions from distant quasars, hoping to spot warped space-time around the emptiness. Even amateur astronomers contribute, their backyard telescopes scanning for anomalies in the void's supposed nothingness. It's cosmic crowdsourcing at its finest, proving that sometimes the most advanced tool in science isn't a telescope, it's teamwork. What makes this collaboration extraordinary isn't just the sharing of data, but the sharing of failure. In most fields, dead ends are buried in lab notebooks. Here, every null result, every observation that finds nothing is celebrated. Why? Because each empty dataset narrows the possibilities, steering the collective effort toward answers. When a Canadian team ruled out one dark energy variant last month, their failed experiment saved researchers in India months of wasted calculations. It's a culture where setbacks become stepping stones and ego takes a backseat to discovery. The void's greatest gift might be this unintended side effect, forging connections across borders. Late-night video calls buzz with debates in half a dozen languages, while shared Slack channels overflow with theories in broken English and hastily translated equations. A Russian astrophysicist jokes that the void's emptiness is matched only by their coffee pots during marathon analysis sessions. The camaraderie is palpable, a reminder that curiosity knows no nationality. Of course, collaboration isn't always smooth. Time zone clashes turn meetings into sleep-deprived marathons, and funding battles simmer beneath the surface. But when a breakthrough emerges, like last month's tantalizing detection of anomalous microwave patterns near the void's edge, the celebration is universal. For a moment, competition fades and the world feels a little smaller. After all, the universe doesn't care about borders or budgets. It hides its secrets in plain sight, waiting for us to work together long enough to notice. This global effort proves something profound. The map to nowhere isn't just a place in space. It's a mirror reflecting humanity's best instincts, our stubborn refusal to accept ignorance, our willingness to unite across divides, and our shared awe at the mysteries still waiting in the dark. Exploring the map to nowhere isn't just a scientific challenge, it's an ethical minefield. When we encounter regions of space that defy every law we've written, who gets to decide what happens next? Do we send probes into the void, risking unintended consequences, or do we observe from a distance, treating it like a cosmic artifact too fragile to touch? These questions aren't hypothetical. History is littered with examples of humanity's curiosity outpacing its caution, from nuclear testing to gene editing. But this time, the stakes aren't confined to Earth. We're talking about tampering with forces we don't understand, in a realm where a single misstep could ripple across light years. One camp argues that exploration is non-negotiable, that the pursuit of knowledge justifies the risks. After all, every major leap in science began with someone daring to poke the unknown. Without venturing into the void, we might never uncover the physics that could revolutionize our understanding of the cosmos. Proponents point to the Large Hadron Collider, where skeptics once feared particle collisions might create black holes. Those fears proved unfounded, and the discoveries like the Higgs-boson rewrote textbooks. Why should this void be any different? But critics counter that the LHC's risks were calculable, while the void's true nature is anything but. What if probing it triggers some unforeseen chain reaction, like disturbing a beehive we didn't know was there? Then there's the question of ownership. Space law, as it stands, is a patchwork of treaties designed for mining asteroids and avoiding orbital conflicts, not for confronting existential mysteries. If this void holds secrets that could redefine energy, gravity, or even reality itself, who gets custody? Nations with the resources to study it, all of humanity. The very idea of claiming such a phenomenon feels absurd, like drawing property lines on a black hole. Yet without governance, the void could become a free-for-all, with competing missions crowding the region like gold prospectors in a cosmic frontier. Ethicists raise another concern, the slippery slope of contamination. Imagine sending a probe into the void, only to discover it's not empty at all, but home to some form of life or phenomenon we can't yet detect. Our instruments might mistake it for nothingness, like deep-sea explorers oblivious to bioluminescent creatures in the abyss. Interfering could amount to an interstellar trespass, violating a domain we didn't even know existed. It's the ultimate paradox. To study the void responsibly, we'd need to understand it first, but understanding it requires studying it. Perhaps the most unsettling thought is that the void might not want to be explored. That sounds like sci-fi paranoia, but consider how Earth's ecosystems react when disturbed invasive species wreak havoc. Climates shift unpredictably. Now scale that up to cosmic proportions. What if the void's emptiness is a feature, not a bug, a cosmic keep-out sign written in the language of physics? Until we know more, treating it like just another research site could be the height of arrogance. The debate boils down to a clash of values, curiosity versus caution, ambition versus humility. There's no easy answer, only the recognition that as our reach extends deeper into the cosmos, so does our responsibility. The map to nowhere isn't just testing our scientific models, it's testing our wisdom. And that's a frontier no telescope can map. The hunt to unravel the map to nowhere isn't just expanding our understanding of the cosmos, it's reshaping the very tools we use to explore it. Confronted with a void that defies detection, engineers and astronomers are pushing technology beyond its limits, inventing instruments so sensitive they can almost hear the universe whisper. At the forefront is the next generation of space telescopes, like NASA's upcoming Habitable Worlds Observatory, designed to peer deeper into the infrared spectrum than ever before. Unlike its predecessors, this telescope won't just capture light, it'll dissect it, searching for the faintest molecular fingerprints in the void's apparent emptiness. Think of it as swapping out a magnifying glass for a quantum microscope, one capable of spotting a single photon lost in the cosmic dark. but telescopes alone won't crack this mystery. The void's greatest trick is its silence, so scientists are turning to unconventional tools to listen instead. Enter the burgeoning field of neutrino astronomy. These ghostly particles, which barely interact with matter, might slip through the void unscathed, carrying traces of whatever or nothing lies within. Projects like the Pacific Ocean Neutrino Experiment are deploying underwater sensor grids the size of cities, hoping to catch neutrinos that pass through the void's heart. It's like trying to study a sealed vault by analyzing the air that leaks through its keyhole. Then there's the dark matter angle. If the void's emptiness stems from some exotic form of dark matter repelling ordinary matter, we'll need detectors capable of spotting the invisible. Laboratories buried deep underground, like Italy's Xenon NT, are racing to refine their sensors to hunt for hypothetical, sterile, dark matter particles that could explain the void's extreme isolation. Meanwhile, quantum gravity sensors, once the stuff of theoretical physics, are being tested in orbit, measuring subtle distortions in space-time that might reveal hidden forces at work. Perhaps most daring are the proposals to send probes, not spacecraft in the traditional sense, but clouds of nanoscale sensors propelled by lasers to fractions of light speed. These stardust probes could reach the void within decades, streaming back data from inside the abyss itself. Critics call it science fiction, but so was the idea of touching the moon once. Every tool we've ever built to study the universe started as an impossible dream until someone made it real. What's striking isn't just the technology, but the philosophy behind it. The map to nowhere is forcing us to rethink not just what we observe, but how. When nature refuses to follow the rules, we don't just need better instruments, we need new ways of seeing altogether. And that's how the greatest leaps happen. After all, the telescope was invented to study the stars, but it ended up teaching us we weren't the center of the universe. Who knows what these tools might reveal? The moment the map to nowhere entered the public consciousness, educators saw something extraordinary, not just a cosmic mystery, but a gateway. Classrooms from Tokyo to Toronto have transformed this void into a living lesson, proving that nothing sparks curiosity quite like the words "we don't know." Take the Hayden Planetarium in New York, where visitors now drift through a 3D simulation of the void, floating through its eerie emptiness while astronomers narrate the science behind it. It's not about giving answers, says director Dr. Neil Tyson. It's about teaching kids to sit comfortably with questions, to see the unknown as an invitation, not a threat. Meanwhile, science curricula are getting creative. In Australia, high school physics students tackle the void as a case study in critical thinking, dissecting raw telescope data to form their own hypotheses. One teacher in Melbourne recounts how a student proposed that the void might be a cosmic echo chamber, bouncing light away in ways we can't detect, an idea that earned her a call with researchers at the European Space Agency. 10 years ago, we'd teach the solar system and stop, the teacher laughs. Now, kids are arguing about quantum fluctuations over lunch. Museums have turned the void into interactive art. London's Science Museum debuted an installation where visitors paint with dark matter, their movements projected as swirling particles that avoid a central black zone, the map to nowhere reimagined as a playground. In Tokyo, a holographic exhibit lets guests step inside the void, surrounded by projections of galaxies that fade to black as they walk deeper, a visceral reminder of scale and emptiness. It's one thing to read about a void, says the exhibit's designer. It's another to feel it swallow you, but the most profound impact might be in underserved communities. Nonprofits are using the void to bridge gaps, shipping portable planetariums to rural schools where kids have never touched a telescope. In one Navajo Nation classroom, students built a scale model of the void using recycled materials, sparking conversations about space, culture, and the stories we tell about the unknown. Their elders talk about the sky as a living thing the teacher shares. Suddenly, Western science wasn't a foreign language, it was another way to honor the mystery. Even toy companies are joining in. A best-selling astronomy kit now includes a mystery cube labeled the Map to Nowhere, challenging kids to deduce why it's empty using infrared filters and mock gravitational readings. It's a hit not just for budding scientists, but for parents who have caught themselves stealing glances at the instruction manual. The best part, says the kit's designer. We don't include an answer key because neither does the universe. What unites these efforts is a shift in how we teach science. Gone are the days of memorizing facts from textbooks. The void has become a symbol of science as a verb, a process of wonder, failure, and relentless questioning. And perhaps that's its greatest gift, not a solution, but a spark. After all, the next generation to crack this mystery might be sitting in a classroom right now, staring at a simulation of nothingness and thinking, what if? Discoveries like the Map to Nowhere don't just rewrite textbooks, they redirect budgets. When a cosmic anomaly this profound emerges, it sends shockwaves through funding agencies, universities, and space programs, forcing them to ask, where do we invest next? Suddenly, missions once deemed too speculative find themselves at the top of the priority list, while long-planned projects face unexpected scrutiny. The void's gravitational pull isn't just metaphorical, it's reshaping the economics of space exploration. Consider the immediate aftermath of the discovery. Within months, NASA Astrophysics Division saw a surge in proposals targeting large-scale cosmic voids, with researchers scrambling to refocus existing telescopes and draft plans for new ones. The European Space Agency fast-tracked funding for Euclid's extended mission, while private donors poured millions into university labs studying quantum fluctuations and alternative gravity models. It's a classic case of scientific demand creating its own supplier. When the universe hands you a mystery this big, money follows the momentum. But this isn't just about shifting existing funds. The void has sparked a broader debate about how we value fundamental research. Critics argue that pouring resources into studying nothingness is a luxury when Earth faces climate crises and pandemics. Proponents counter that history's greatest technological leaps, from GPS to medical imaging, stemmed from curiosity-driven science. The Map to Nowhere isn't just a hole in space. It's a litmus test for how society balances immediate needs against the long game of discovery. The ripple effects extend beyond academia. Aerospace companies are racing to develop specialized probes capable of enduring the void's extreme conditions, while startups pitch AI platforms to analyze its anomalies. Even cryptocurrency speculators have mused about Voidcoin, a satirical nod to how quickly cosmic mysteries get commodified. It's a reminder that when science stumbles onto the unknown, capitalism isn't far behind, for better or worse. Yet the most profound economic impact might be invisible. By forcing us to question foundational physics, the void could eventually unlock technologies we can't yet imagine. Dark energy research once seemed esoteric until it revolutionized our understanding of the universe's fate. Today's grant proposals targeting the Map to Nowhere might seed tomorrow's warp drives or energy breakthroughs. After all, the universe's greatest innovations often start with a simple question. Wait, why doesn't this make sense? The void's true cost isn't measured in dollars, but in opportunity. Every dollar spent chasing its secrets is a dollar not spent elsewhere. But if history's any guide, betting on humanity's hunger to understand the inexplicable has always been a wager worth making. What makes the map to nowhere so extraordinary isn't just the science, it's the people. While professional astronomers grapple with billion-dollar telescopes, some of the most exciting discoveries are coming from backyards and basements. Citizen scientists, armed with nothing but curiosity and home computers, are playing a vital role in cracking this cosmic puzzle. Take the story of retired schoolteacher Martin Fields, who spotted an unusual temperature fluctuation in public telescope data while sipping coffee at his kitchen table. His flagged anomaly turned out to be a crucial clue, leading researchers to reevaluate how light behaves at the void's edges. Platforms like Zooniverse and Galaxy Zoo have become digital meeting grounds where amateurs and professionals collaborate in real time. Volunteers sift through thousands of telescope images, tagging potential anomalies that algorithms might miss. It's like a global game of cosmic Where's Waldo, except the stakes are far higher. One college student in Brazil recently identified a cluster of faint stars drifting near the void's perimeter, stars that had been dismissed as noise by automated systems. These human eyes caught what machines overlooked, proving that pattern recognition isn't just about processing power. Then there's the distributed computing revolution. Projects like Einstein at Home harness idle computing cycles from volunteers' devices worldwide, creating a virtual supercomputer capable of crunching void-related data 24/7. Imagine 500,000 smartphones teaming up to simulate dark matter behavior or analyze gravitational lensing patterns. The result, research that would take traditional labs decades gets done in months, all powered by everyday people donating screen time. Even social media has become an unexpected research tool. Amateur astronomers on Reddit and Discord crowdsource observations, pooling backyard telescope data to track subtle changes in the void's apparent size. When a hobbyist in Norway noticed an odd glitch in her star-tracking software, the community realized it wasn't a bug, it was a previously unnoticed gravitational lensing effect caused by the void's extreme emptiness. What began as a frustrated forum post became a peer-reviewed paper with dozens of citizen co-authors. The beauty of this collaboration lies in its democracy. You don't need a PhD to contribute, just passion and a willingness to learn. High school students analyze spectral data alongside Nobel laureates. Retired engineers build homemade radio telescopes to monitor the void's radio silence. Artists visualize the data in ways that reveal patterns scientists hadn't considered. This isn't just about outsourcing labor, it's about expanding perspectives, proving that the next breakthrough might come from anywhere. Or anyone. Perhaps the most inspiring aspect is how these efforts bridge generations. At star parties from Chile to Canada, grandparents and grandchildren team up to photograph the void sector, comparing notes with researchers via live stream. One 9-year-old's hand-drawn diagram of how the void might push galaxies away recently went viral in astronomy circles, not for its accuracy, but for its imaginative approach. Kids ask questions we've forgotten to consider, admits one astrophysicist, like whether the void is lonely or if it's growing on purpose. This grassroots movement underscores a profound truth. Some mysteries are too big for any one institution to solve alone. Whether it's a teenager coding a new data filter or a nurse spending nights classifying telescope images, each contribution stitches another thread into our collective understanding. The map to nowhere may be a blank spot in the cosmos, but the effort to decode it has become a vibrant tapestry of human curiosity, one that proves science belongs to everyone. From breathless headlines comparing the void to a cosmic horror show to sober scientific explainers, media coverage of the map to nowhere has become a case study in how journalists grapple with the unimaginable. The moment the discovery broke, newsrooms faced a dilemma: How do you explain a phenomenon that defies textbook physics without veering into clickbait? Major outlets like the New York Times and Nature struck a careful balance, with headlines like "Astronomers stumble upon a void that defies explanation," paired with detailed infographics showing how the anomaly challenges cosmological models. But tabloids seized on the void's eerie mystique, splashing phrases like "gateway to another dimension," alongside doctored images of swirling black holes despite the void having no relation to black holes whatsoever. What's fascinating isn't just the range of coverage, but how quickly narratives diverged. Science communicators emphasized the void's potential to rewrite physics, while conspiracy forums latched onto its emptiness as proof of everything from alien megastructures to divine intervention. Even reputable platforms occasionally stumbled. One widely shared National Geographic piece initially described the void as expanding, a mischaracterization that took days to correct, fueling misguided theories about it consuming nearby galaxies. The era revealed a deeper challenge. When reporting on frontier science, even minor linguistic choices like calling it a hole instead of a low-density region can distort public understanding. Social media amplified both the best and worst of the coverage. TikTok explainers from astrophysicists like Dr. Katie Mack garnered millions of views, distilling complex concepts into digestible clips. Yet these coexisted with viral posts claiming the void was NASA's biggest secret or evidence we live in a simulation. The algorithm rewarded sensationalism, pushing debunked claims alongside peer-reviewed research. Researchers found themselves battling not just scientific ignorance, but a deluge of misinformation designed to exploit the void's inherent weirdness. Behind the scenes, scientists and journalists navigated ethical tightropes. Should they emphasize the void's mystery to capture attention, risking oversimplification? Or prioritize nuance, knowing it might alienate casual readers? Some teams, like the BBC's Science Unit, adopted a pyramid approach, starting with bold hooks. The universe has a hole in it, before layering in caveats and context. Others, like Scientific American, opted for relentless precision, even if it meant fewer clicks. The difference in reach was stark. A flashy YouTube documentary on the void racked up 10 million views in days, while a meticulously sourced Quanta article took weeks to gain traction. The coverage also exposed cultural divides. In Japan, where astronomy enjoys mainstream popularity, NHK's primetime special blended serene visuals of the void with haiku-inspired narration, framing it as a meditation on Ma, the beauty of empty space. Meanwhile, German media leaned into the void's potential to upend Ordnung, the ingrained love of cosmic predictability. These variations weren't just stylistic, they reflected how different societies process scientific uncertainty. Perhaps the most telling trend emerged in late-night comedy. Hosts from John Oliver to Trevor Noah used the void as a metaphor for everything from political scandals to dating apps, proving its grip on the zeitgeist. Scientists found a place where nothing exists, joked one. I've been preparing for this my whole life, just ask my high school gym teacher. This mainstreaming, while often superficial, served a purpose. It made cosmology conversational, bridging the gap between academia and pop culture. The Map to Nowhere's media saga underscores a truth science communicators know too well. Extraordinary discoveries demand extraordinary care in storytelling. Get it right and you inspire the next generation of astronomers. Get it wrong and you feed the very myths that obscure real progress. As the void's mystery deepens, so does the responsibility to share it, not as a cosmic boogeyman, but as a testament to how much we have left to explore. Artists and filmmakers have transformed the map to nowhere from a scientific anomaly into a canvas for the human imagination, blending cosmic mystery with breathtaking creativity. Take the digital installation event Horizon by artist Ryoji Aikta, where visitors walk through a pitch-black corridor while subsonic vibrations mimic the void's eerie silence. The piece doesn't just depict emptiness, it weaponizes it, using sensory deprivation to make the audience feel the weight of absence. Scientists praised its accuracy in one unexpected way. The installation's disorienting effect mirrors how light itself seems to falter at the void's edges, as if space-time loses its grip. Film directors, too, have seized on the void's unsettling potential. In the indie sci-fi hit Voidbound, the anomaly isn't a backdrop but a character, a sentient nothingness that swallows astronauts' memories along with their ship. The filmmakers consulted astrophysicists to nail the physics of light distortion near the void's perimeter, using actual telescope data to render its gravitational lensing effects. One scene shows a crew member's face stretched and warped as they drift closer, their image smeared like paint across an invisible canvas. It's poetic license, yes, but rooted in real science. Einstein's equations predict exactly this kind of light bending around extreme low-density regions. Then there's the viral Cosmic Blank project, where generative AI transforms the void's radio silence into music. Composers fed decades of cosmic microwave background data into machine learning algorithms, training them to listen for patterns in the void's apparent nothingness. The result, a haunting symphony of gaps, notes that aren't played, spaces where harmonies should be but aren't. Astrophysicists were divided. Some dismissed it as artistic whimsy, while others admitted the composition's structure eerily matched mathematical models of quantum vacuum fluctuations. Visual artists have taken a more tactile approach. Sculptor Lena Ivanova's The Missing Piece, a polished obsidian sphere with a perfectly smooth, concave void at its center, plays with scale and perception. Viewers report an uncanny urge to reach into the hollow, as if their hands might vanish into another dimension. "I wanted to make the void tangible," Ivanova explains, "something you could almost hold, even though it's defined by what's not there." The piece inadvertently echoes a cutting-edge theory in cosmology, that the void might be a topological defect, a literal hole in space's geometry left over from the universe's birth. Even video games have embraced the challenge. The indie puzzle game Eventide tasks players with navigating a ship through a void that warps the rules of physics. Dark matter clouds deflect sensors, fuel drains unpredictably, and landmarks shift due to relativistic effects. Developers worked with astronomers to ensure these mechanics weren't just gimmicks. They reflect genuine hypotheses about how matter or its absence might behave in such extreme conditions. One level where players must sail, using cosmic microwave background radiation as wind, impressed physicists for its clever analogy to real-world navigation techniques being proposed for future void probes. What unites these works isn't just their creativity, but their role as bridge builders between science and the public. When equations fail to convey the void's strangeness, a sculpture that makes your skin prickle or a game level that leaves you dizzy can succeed. Artists become translators, turning abstract data into visceral experiences, and sometimes their visions circle back to inspire the scientists themselves. After all, the universe's greatest mysteries have always demanded more than telescopes and equations. They require us to stare into the abyss and dream. Not every astronomer is ready to rewrite the textbooks over the map to nowhere. In fact, a vocal contingent argues this cosmic oddity might be less a groundbreaking discovery and more a case of measurement error magnified by wishful thinking. Their skepticism isn't born of cynicism, it's the lifeblood of good science. After all, extraordinary claims require extraordinary evidence, and some researchers insist the void's impossible emptiness could have far more mundane explanations. Take the calibration argument. Modern telescopes are marvels of engineering, but they're not infallible. A subtle misalignment in a spectrograph or a glitch in data processing could theoretically mimic the signature of an empty void. Dr. Lena Petrov, an instrument specialist at Caltech, points out that similar false alarms have happened before. In 2014, a team thought they detected primordial gravitational waves in the cosmic microwave background, until further analysis revealed the signal was cosmic dust all along. The universe doesn't conspire to trick us, Petrov notes, but our tools sometimes do. Then there's the cosmic forensics angle. The void's apparent emptiness hinges on what we don't see, a dangerous foundation for any scientific claim. Critics argue we might be missing faint, diffuse matter that current telescopes can't detect. Imagine shining a flashlight into a foggy valley and declaring it empty because you can't spot any trees. That's the risk here. Radio astronomers like Dr. Miguel Santos are quick to remind us that hydrogen clouds, the universe's most elusive gas, often evade optical surveys. Until we've scoured the void with every wavelength from radio to gamma rays, labeling it empty might be premature. Statistical flukes also loom large. In a universe this vast, even the most improbable configurations must occur somewhere. Cosmologist Dr. Hannah Zhu compares it to shuffling a deck of cards. Deal enough hands, and eventually you'll get 13 spades in a row. We're playing with a cosmic deck of trillions, she says. Finding one weird void doesn't necessarily break the game. Her simulations show that while voids this extreme are rare, they're not impossible under standard models, just extraordinarily unlikely. The real question isn't whether such anomalies can exist, but whether we're seeing a true outlier or just sampling bias in our observations. But the most compelling counterargument comes from Occam's razor, the principle that the simplest explanation is usually correct. Before invoking new physics or multiverse collisions, shouldn't we exhaust every conventional possibility? That's the stance of Dr. Rajiv Mehta, who leads a team cross-checking the void's parameters against historical sky surveys. Science advances by killing its darlings, he says. If this void survives every attempt to disprove it, then we've got something revolutionary. Until then, skepticism isn't just healthy, it's mandatory. This tension between discovery and doubt isn't a flaw in the scientific process, it's the process itself. Every paradigm-shifting finding, from plate tectonics to dark matter, endured fierce skepticism before acceptance. The map to nowhere is no different. Whether it ultimately proves to be a measurement error, a statistical oddity, or a genuine cosmic revolution, the debate it sparked is already a victory. Because in the end, science doesn't progress by chasing certainty. It thrives in the space between we know and we wonder, precisely where this void has left us. If the map to nowhere is confirmed as a genuine cosmic anomaly, not just a fluke or measurement error, it won't just challenge our understanding of the universe, it will shatter the foundation of modern cosmology. Textbooks, lecture halls, and research agendas would undergo a seismic shift, rewriting chapters we once considered settled science. Picture a future where students learn about the void not as a footnote, but as the catalyst that forced us to rethink the universe's very architecture. First to fall would be our models of cosmic structure. For decades, the lambda-CDM model, the reigning framework describing how matter and dark energy shape the universe, has predicted a predictable web of galaxies and voids. But if a region this vast and empty exists outside those rules, the model would need radical revisions. It's like discovering a city that defies gravity. suddenly, every urban planning textbook becomes obsolete. Cosmologists might have to introduce new variables, perhaps a previously unknown force that repels matter in extreme low-density environments, or a flaw in our understanding of how dark energy operates on galactic scales. The void wouldn't just be an exception, it would be proof that our equations are incomplete. Then there's the Big Bang's aftermath. Our current theories suggest the universe's initial fluctuations were smooth, like ripples in a pond, leading to the cosmic web we see today. But the map to nowhere's sheer emptiness suggests something far more chaotic, a primordial glitch in the fabric of space-time that never smoothed out. Future textbooks might describe the early universe not as a uniform expansion, but as a turbulent sea where pockets of nothingness could survive billions of years untouched. This wouldn't just change cosmology, it would redefine how we study the universe's birth, forcing us to question whether the Big Bang was truly as orderly as we've imagined. Dark energy's role would also come under scrutiny. If the void's emptiness stems from dark energy behaving differently in certain regions, we'd need to abandon the idea that it's a uniform force. Instead, dark energy might become more like weather, patchy, variable, capable of creating cosmic deserts where matter is scoured away. Imagine a chapter in astrophysics class titled Dark Energy Climates, teaching students how to map these invisible currents the way we track ocean tides. The implications would ripple beyond academia, too. If dark energy isn't constant, our predictions for the universe's fate, whether it will keep expanding or eventually tear itself apart, might need to be tossed out. Even the philosophy of science would feel the aftershocks. The void's existence would force us to confront an uncomfortable truth, that the universe isn't obliged to make sense to us. Future historians might look back on this era as the moment we realized our models were just approximations, like Newton's laws before Einstein. It's humbling, but also exhilarating, a reminder that discovery isn't about filling in the blanks, but realizing how many blanks we never knew were there. And what if the void hints at something even wilder, like evidence of a multiverse? If textbooks one day include diagrams of our universe brushing against another, leaving behind this scar of emptiness, it would be the ultimate paradigm shift. Suddenly, concepts reserved for theoretical physics could leap into mainstream science with the map to nowhere as their smoking gun. The real revolution, though, might be in how we teach curiosity itself. Future students could grow up seeing the void not as a mystery to be solved, but as a lesson in humility, a cosmic reminder that the universe always has another card up its sleeve. After all, the most exciting discoveries aren't the ones that answer our questions. They're the ones that show us how much we've yet to ask. If the map to nowhere were truly unique, it might be written off as a cosmic fluke, a one-in-a-trillion accident. But what if it's not alone? Astronomers have turned their telescopes to the skies, scanning for other voids that defy the rules, and what they're finding is both thrilling and unnerving. The hunt for more nowheres isn't just about cataloging empty spaces. It's about uncovering whether our universe has a hidden pattern, a secret signature written in negative space. The search begins with archival data. Teams are poring over decades-old sky surveys, reprocessing the numbers with new algorithms sensitive to extreme emptiness. It's like revisiting a familiar family photo and suddenly noticing a shadowy figure in the background, one that's been there all along. Already, a handful of candidates have emerged, regions where the galaxy count dips suspiciously low, where the cosmic microwave background shows odd fluctuations, or where distant quasars seem to dim as if something unseen is blocking the light. None match the map to nowhere's staggering scale, but their mere existence hints that this phenomenon might not be a solo act. One particularly intriguing candidate lies in the constellation Pegasus, dubbed the silent patch by researchers. Preliminary observations suggest it's not just sparse, it's eerily quiet, with even the faint radio hum of the universe's background radiation noticeably dampened. Then there's the southern void near the Large Magellanic Cloud, a region where star formation appears to have stalled entirely, as if some invisible barrier is keeping matter out. These anomalies aren't as extreme as the map to nowhere, but they share its unsettling vibe like cosmic dead zones where the rules don't quite apply. But confirming these voids is trickier than it sounds. Unlike black holes or supernova, which announce themselves with bursts of energy, voids are defined by what's not there. Detecting them requires painstaking comparisons, mapping the expected distribution of galaxies against the observed emptiness, then ruling out every possible alternative, from telescope glitches to intervening dust clouds. It's forensic science on a galactic scale, where the absence of evidence is the evidence. Some teams are even employing machine learning to spot subtle voids in datasets too vast for human eyes, training algorithms to recognize the fingerprint of nothingness. The stakes couldn't be higher. If multiple nowheres exist, it would suggest that our universe isn't just messy, it's fundamentally patchy, with pockets where the usual laws of physics take a backseat. Picture a stretch of highway where the speed limit randomly drops to 0 for miles at a time. That's the kind of cosmic reality we might be facing. Some theorists speculate these voids could be scars from the universe's birth regions where inflation, the rapid expansion after the Big Bang, hiccuped and left behind bubbles of abnormal space. Others wonder if they're evidence of a deeper structure, like cracks in a frozen lake, hinting at forces we've yet to name. Yet the most tantalizing possibility is that these voids are connected not physically, but statistically. If they cluster in certain parts of the sky or follow a specific size distribution, it could reveal an underlying mechanism shaping the cosmos in ways we've never imagined. Imagine tossing a handful of pebbles into a pond and noticing that the ripples intersect in precise geometric patterns. That's the level of order astronomers are searching for in the chaos of nothingness. For now, the hunt continues, with every new survey and space telescope adding pieces to the puzzle. The James Webb Space Telescope's infrared eyes are peeling back layers of cosmic dust to probe suspected voids, while the upcoming Nancy Grace Roman Telescope will map the large-scale structure of the universe with unprecedented precision. Each observation brings us closer to answering the ultimate question: is the map to nowhere a cosmic loner, or just the first whisper of a much weirder reality? One thing's certain: if more voids like it are out there, the universe just got a lot stranger. The map to nowhere isn't just a cosmic oddity, it's a wake-up call, a reminder that the universe thrives on defying expectations. For all our equations and telescopes, for every law of physics we've etched into textbooks, the cosmos still holds corners that leave us speechless. That's the magic of discoveries like this. They don't just add to our knowledge, they humble it. Imagine spending centuries mapping the ocean, only to stumble upon a whirlpool that drains into nothing. That's the scale of this void's defiance, a cosmic shrug in the face of human certainty. Yet here's the beautiful paradox: the more we uncover, the more we realize how much we don't know. Every mystery solved seems to unlock two more, like a celestial nesting doll of questions. Take dark matter, we've known about it for decades, yet it remains as elusive as ever. Or quantum mechanics, where particles teleport and spin in ways that mock common sense. The map to nowhere slots right into this grand tradition, a puzzle that refuses to fit neatly on our shelves of understanding. And honestly, that's what makes science so exhilarating. If everything clicked into place, we'd stop looking up. This void also underscores something deeper about our place in the universe. We're not just passive observers, we're detectives piecing together a story written in stardust and silence. Every anomaly, every contradiction is a clue not just about how the cosmos works, but about how we think it works. When our models fail, it's not a defeat, it's an invitation to dream bigger. After all, Einstein didn't overturn Newton by tweaking his math. He tore up the rulebook and started fresh. Who's to say the next revolutionary idea isn't lurking in this very void, waiting for the right mind to connect the dots? So what's next? The hunt for answers is already morphing into something even more ambitious. Astronomers are designing telescopes capable of peering deeper into the void's emptiness, while theorists sketch equations that might explain its existence. Some are even reimagining the fabric of space-time itself, asking whether we've missed a hidden dimension or a shadow force tugging at the cosmic web. And let's not forget the amateurs, the backyard stargazers, and citizen scientists whose fresh eyes might spot what the professionals overlook. This isn't just a job for the elite, it's a collective adventure, a reminder that the universe belongs to anyone brave enough to question it. As we close this chapter, one thing's certain: the map to nowhere won't be the last surprise. The universe is too vast, too clever, too weird to ever run out of tricks. Maybe the next great anomaly is already hiding in plain sight, disguised as static in a radio signal or a blip in a dataset. Or maybe it's something we haven't even thought to look for yet. That's the thrill of the unknown, the sense that no matter how much we learn, the cosmos will always have one more card up its sleeve, so keep watching the skies. Keep questioning, because the greatest discoveries aren't just about finding answers, they're about realizing how many questions we've yet to ask. And if a patch of nothingness can upend our understanding, imagine what else is out there waiting in the dark.